Now that we know for the general book design is actually very good for storage, but very bad for retrieval, let's see what the ultimate solution would be to really make the retrieval much more disciplined. So let's see what the requirements for the solution would be. So we want to eliminate all the runtime assertion violation due to run casts. We want to eliminate all the class cast exceptions that we might run into at the runtime. And also we want to really get away from explicit attached checks, like an instance of checks and also typecast. They will actually violate the single choice principle very badly, as we illustrated. So we really want a solution to really satisfy these two criteria. How can we do it? Let's sketch the solution. But I can tell you that the ultimate solution is really the generic class that we spoke about from the code reuse point of view previously. So when the user declares a book of type declares a book for object B, so they must commit to what kind of record the B is going to store at the runtime. So you want to commit either to string or to dates, either way, but not both. And then, for example, if you say B stores either the date objects or its descendant classes, right? So whatever type you actually choose to be, so any of its descendant classes will be able to satisfy its expectations. So that's why descendant classes will also be allowed, right? So you got to be careful with the choice you made. So when attempting to store new records into the book B, so now depending on what you commit to, if you actually commit to the dates, you can only store dates and its descendant classes into the book. If you commit to string, you can only store string or its descendant objects into the book. Okay, so it will be considered as compilation error if you say it's a book for the dates, but actually store the string objects. I will illustrate to you by using the original code. Okay, so now rather than triggering a runtime assertion violation like a class cast exception as we illustrated previously, now you want to make sure you can catch those errors at the compile time. So that's a fundamental improvement by using generic classes as opposed to array of any. So that's a very critical point over here to see, but I will illustrate to you in just a moment. Okay, and then when you try to retrieve a record from the book, so there should be no longer a need to check and cast. So that's very important. So these are the two criteria that we want to satisfy by using generic classes. And also, this is also very important. By using generic classes, we no longer have to do any cast. So that means we can be free from any class cast exception or runtime assertion errors at the runtime. Okay, so now I would like to just go over very quickly with you about this generic book. So you have seen the syntax already for generic book, so I'm not going to bother you with that. Okay, let's just see this. So we talk about you should really distinguish between supplier versus the clients. You can see this is the supplier side, in which case we simply declare at the class level some generic parameter. It can be as many as you like. And then just to repeat very quickly from your previous learning. So this will be the declaration. And then this, these three will actually be the usage of the generic parameter, right? So we spoke about this already. And that's about the supplier. And let's talk about the clients, the client side. This is very important. Okay, so now on the client side, whenever you're using a generic class, you must instantiate the generic parameter to be some known type. So now this will be the dates. So once you commit to this choice, everything will be working accordingly by the compiler. So now when you actually create, okay, there should be a slight typo here. There should be curly brackets over here. Just don't forget, you should put a dynamic type. And whenever you put a dynamic type, a common error is you forgot to instantiate the generic class. Just be careful. You want to remember that. So now we want to consider these lines over here. In the previous example, it used to be the case that this will compile, and also this will compile because the storage is very generous, right? And in the previous one, this wouldn't compile. That's from the previous general book design. Let's revisit these three lines very quickly. Okay. So now, will this compile over here? The answer is no, it wouldn't compile anymore because as soon as we commit the member to be a dates, so that means we're instantiating this to be a dates. And then every occurrence of G is going to be instantiated into dates accordingly. So now, if you talk about add over here, only the dates and also its descending classes will be allowed. Is string a descending class of dates? No, so it wouldn't compile. On the other hand, the birthday over here, it will compile. So that's the number one difference, right? You can see now we're just getting more restrictive on storage. Okay, so now what used to be not compiling, would it now compile? Over here, it will compile because now b.get over here, statically what will be the return type? Well, since we already commit to the dates, so that means the get over here is going to be instantiated to be a dates. So now that means we always return a dates. Dynamically can be any descending class of the dates, but statically we can always assume it will satisfy the expectation for dates. So this part here is going to be static type of dates. And of course, get day of the week will be within the expectation for the date. So this will compile. Okay, so now you can see for the retrieval does not require cast. And this line here will just compile. Okay, so hopefully you can see what's going on over here. All right, so that's about a very quick walkthrough about the advantages for this particular generic design over here. So, but you really want to contrast between the general book versus generic book to really see the difference. Okay, let me go back to the slides. Okay, so that, something about parameters, just to really review very quickly to talk about why we call that generic parameter. If you think about back in mathematics, if you got different operation you want to perform on the addition, different input values over here, so the way to really make this more general is to make the first one as a parameter maybe x, and the second one being another parameter y, and then you can simply declare this function over here. Let's say we have a function called addition, and then it's simply going to be an integer followed by another integer x and y. So that's just basically the parameter idea in the math. The main point is I want to show you that generic parameter is not a unique idea. So it has been there since when you learn mathematics. Okay, what about in OOP? So let's say this. If you want to support, let's say, account objects that deposit some value over here and also another value over here, you can generalize these argument values into parameters. For example, you can say, I now, every time I call deposit, there should be a parameter called amount. So the similar idea would be when we talk about generic classes. So now when you actually talk about generic classes, we want to say for every member over here that we actually want to use for this particular class, we want to generalize them into a single parameter that's declared over here at the class level. That's similar to both in the context for math and also for OOP. So that's the main point I want to carry through to you. Okay. Okay, so now this is the generic class that we just spoke about, and now you want to review and also convince yourself why this line wouldn't compile anymore. This line remains to compile, and this one that used to not to compile in the general book design, but now it compiles, and even without the class cast. Okay, that's something you want to review. All right, so this part here is simply just something we have already illustrated on the iPad. So this one here, just repeating the details, but you can review it again, just like a written form for the arguments about which line that will compile and which one will not compile by using generics. Okay, so now I would like to give you one little quiz over here. So given, let's say we are using the book, the generic book over here, but now, do you think having an instantiation of the member type to be from G to any, do you think this is actually a good choice? Okay, think about it. And if you do believe it is good, think about why. If you believe it's a bad choice, think about why not. Okay, assuming that you have thought about it, this is very, very, very bad choice of using a generic class over here. If you really think about what you're doing here, if you simply say any over here, so what you're doing is you simply instantiate this to be any, meaning that every occurrence of G will be instantiated by any as well. So you're basically going back to the any over here. So that means it's really no difference between the generic book versus a general book in this case, if you simply instantiate G to be any. So that's a very, very, very bad choice that you are making over here. Okay, just understand why. So using the generic class doesn't really mean it's always error-free or design principle violation-free. You want to make sure you're instantiating the class appropriately. Okay, it allows all kinds of objects to be stored as I just illustrated, and then it would be as if you simply just use the general book. You can expect very, very little from the object that's retrieved from calling the get query. Okay, and then let me see, exhaustive. Okay, so this is the thing. You still have to do an exhaustive list of the cast, even though you're using generic class, because you made a very bad choice about the instantiation. Okay, so now let's make some concluding remarks. So let's talk about the general use of the generics. But I think from your lecture series number 4, when we talk about the iterated pattern, that exercise over there at the end about how you can instantiate generic parameter, that one is a much more advanced example than this. So I'll just talk about this very quickly. Okay, but I would suggest that you actually review that lecture series number 4, the exercise about filling in the generic parameters for the iterated pattern. I think that'll be a very good review at this point. Okay, so let's say we got dictionary. Let me just switch to iPad over here to show you quickly about my point here. So let's say you got generic class, you got v, you got k. So these are the generic parameters. And then at entry, you're simply reusing v and k. And for remove entry, you also use k, right? So that's a generic class. No question about it. And then let's say you're trying to make use of this particular generic class. So that we talk about clients of this particular class. So how can you use it? So now let's say we have a client class called database table. And that one, they got k and v. So now for this particular client class to use the dictionary, which we define over here, right? We want to instantiate a v by something. We want to instantiate a k by something. So now for the clients, it's up to their judgment about whether the k should really correspond to the k here or the v here, right? It's really up to them. But I would say typically if you're the same developer for the two classes, you better make the names consistent. But if you're using other people's class, then the name may not be consistent, so you got to be careful, right? You got to think about two scenarios. But now we'll simply just say whatever instantiation this k might be, I'm going to use the k for the k over here. And whatever v is instantiated, I'm going to use the v over here. Let's take some example. Let's say this is client number 1. Let's say there's another client number 2 who is going to make use of this particular class, right? So now, when we say database table, we are trying to make use of this class here. And then we instantiate a k by integer, and also instantiate a v by string. Effectively, it will actually affect the instantiation for the dictionary, which is made use by C1. In that case, the v string over here will just be the string over here. And the k integer will just be the integer here. Right? That's simple instantiation. And then another point to make. So now we have another example class over here. Let's say we have a student book over here, right? The student book is only got one generic parameter. And then in that case, the dictionary, you can see we are making use of the v over here to instantiate the k. Oh, sorry, we're using the v over here to instantiate the v over here. However, for the k, we are not making use of any generic parameter from this particular class. We simply say it's always fixed to be a string, right? It's just another way to use a generic class. So now, if you try to think about this is C3, and let's got another class C4, right? We're trying to make use of this class over here. So now when we say student book, okay, we are using this class over here. So now if I can instantiate this by, for example, array of course, right? So now I can say student book is going to be an array of course. What that would do is it's going to internally create a dictionary where the v over here is just going to be instantiated by array of course. So that's a student book, right? Every student has the record for their list of courses, okay? So that's exactly what I just illustrated here. Okay, so these examples are not really difficult. You just have to be careful when you actually do the instantiation for your generic classes. Okay, so finally, there are two diagrams I would like to speak about from the slides, and then we are done for this lecture here. Okay, let's just the first diagram is really about how do you compare generics versus inheritance. So thinking this way, when you are doing generics, it's really about parameterization for the member type for the collection. Okay, so type parameterization, this is about generics. Okay, so now you can have maybe a list of people. Okay, this is one type, or you can have a list of book, or you can also have a list of journal. So these are the just three example possibilities. So people and book and also journal. So these will all be parameterized by the type G. So when you declare your particular class, you can simply say list of G. All right, that's why when you define this particular library class, you will say class list of G. And the G over here can be instantiated by any of the class, for example, people, book, and journal. So that's about type parameterization. We're just introducing a parameter that can be instantiated by many different values. So that's about the horizontal aspects for your design. Okay, type parameterization. Let's talk about the vertical aspect. It's more like a inheritance hierarchy. So when we talk about inheritance, it's really about abstraction, okay, versus specialization. You can think about the lower you are in the inheritance hierarchy, the more specialized you are for the classes, meaning that you can have more expectation on that particular class. So now you can see over here, so we got a set versus a list versus a linked list. So think about the set is simply the top level of the hierarchy is inherited by the list. And also it's also inherited by the linked list over here. So we got three classes of the inheritance over here. So now think about the linked list over here is actually lower, strictly lower in the hierarchy than the set. So that means for the linked list, it's actually more specialized. It's actually more specialized than, for example, the set, which means you have more features expected. Okay, so these are the two orthogonal or independent aspects for design. Either you want to use, whenever you want to talk about abstraction versus specialization, you can use inheritance, right? About creating the hierarchy. On the other hand, if you got potentially many different types for your collection or for your class members, in that case, you can use generics for parameterization for the types. Okay, that's number one. There is another diagram I would like to talk about. Okay, it's pretty much the same. Okay, you can think about it as the same diagram. Again, we talk about horizontal over here, horizontal for genericity, type parameterization, and also we got the vertical aspects for generalization or the specialization, right? So these are the two orthogonal aspects for design that you want to pay attention to. I would say this diagram here might be a little bit more illustrative, but this diagram here just talk about something that's consistent. Okay, so that's about the end of this lecture here about generics. It's just some slight extension to what we spoke about polymorphism and typecasting. You want to really know about the difference between the two books, either general versus generic, and what the pros and cons are for each one of them. Okay, so now optionally, we already referred to you about this particular tutorial video series, just about how you can use generic parameters and also iterate a pattern, which you already knew from the previous lab and also lecture. So optionally, if you haven't looked at the video, you can feel free to look at that. That might also help you understanding for using generic classes.